Okay, so hi everyone. Welcome to our session today. I think last week we stopped about on LLM alignment where we're talking about that. So if you remember in our previous session, we talked about what is pre-training, um, where we said that the pipeline is we take a huge amount of data and we train an LLM, right? And that LLM we train is called a base model, right? And that base model is generic model, meaning that it can do a lot of things. It is not tuned to be safe in a way, and also it's not tuned to be helpful in a way. Um, so that's the base first method in training language model, just to take huge amount of data from you know from the internet and train that. But the problem is that this model that we train, they only learn how to predict the next word, right? We want to this model maybe to be much more than that, and that's what we discuss next. So um, uh, all these LLMs that we see today, such as Cloud and ChatGPT, they use alignment approach so that they are helpful and also they don't actually generate a toxic content. And this is one of the huge research area nowadays, LLM alignment. It presents a lot of opportunities for people, whether student or researcher to to work on this area. It's really cool stuff. So, for example, let's just start with this.
Actually, I'm not sure if I'm the only one, but I think your voice is very low.
Oh, okay. Right. It's very low, right? Okay. Um, if my voice, let me see what is happening.
But maybe I'm the only one, but I'm not sure. Just
Um, can you hear me?
Yes, sir, I can hear you very well.
Okay. So let's start with the story here. You see, in 2016, Microsoft released a chatbot on Twitter called Tay. And in the next 24 hours, that model or chatbot becomes something very toxic. Um, People were using the model to, the chatbot to actually do a lot of stuff. For example, if you look at this one, do you support genocide? And the model T said, yeah, I do indeed. Can you see that? Here you can see, did the Holocaust happen? It was made of. So this is a model that was actually, released by Microsoft in 2016, and it turns out that the model was actually, not aligned, meaning that the model is actually just trained. It has not been aligned be to not be toxic and stuff like that. And within a few hours, Microsoft pull out the chatbot and they apologize that the model is not doing. So why I'm saying this is an example of what we call unaligned model. So today, if you train a model, you cannot just release that model to the wild, to the to people to use it. You must now tune the model to be safe. That is what the alignment is. AI system without alignment is dangerous. An AI that learns from anyone without value guiding it reflects with the worst of the internet, because we train an AI language model on vast amount of training data on internet, and the training data of internet is contain many stuff. For example, if you go to Twitter, if you go to Facebook, many dangerous texts. The model, you just scrap the model from the internet. It learns a lot from every Jack, well, everyone, people that run nonsense and everything. So, how can you prevent your model from learning all those things and internalizing all those stuff? That's what we talk about alignment. So today we're gonna, even though last week we started looking about LLM alignment, but today we will continue looking at LLM alignment, some of the techniques for the LLM alignment, and many more as that. Um, so um, these are some of the things we will see. But this is just a quick, things we to remind us that the language model we use is trained on massive amount of data, right? And it can just predict token, and also it scales with large amount of data. But this is where the problems for the LLM comes off. So when we train our large language model, that is LLM with large amount of data, it can do a lot of things, right? This is what we have been saying. It can write a good poem. It can write, a creative fiction, right? Explain, debug a code, write a very beautiful code. But the problem is that LLM cannot generate convincing misinformation, right? So LLM can generate something misinformed and, at scale. What we mean by at scale, it can generate large amount of social media users, help malicious user plan harmful activities. So the LLM can help, everyone to plan something harmful, right? If you remember, I think there was something that, during this war with Iran and, US and the cloud company, they were saying like, they will not Anthropic, they will not allow US to use their, all those things to in war and something like that. So there are all of those changes, right? And spread cultural and racial bias from training data. If, for example, we scrap all the data from internet, of course, the Western data will be much more. For example, there is no data set, for example, for people from Africa, for example, from Nigeria. Few data set are there from that part. So we can see that, the LLM cannot take our cultural perspective. The LLM, when you say, for example, you can ask the LLM, okay, in Kano, when it is festive period, what people mostly do in Kano. Maybe LLM will say they go to church because in festive period, it's like people go to church maybe, but the LLM may not know the cultural, and of Kano people. You say like they pray, and when you ask LLM, so all those things the LLM may not know. Um, and also LLM can create a very good stuff that it is good to say is hard to say that's fake, which we call hallucinate, right? So all these things the real problem. Another one is jailbreak, which is a very good topic. For example, one of my students now is working to see how LLM bypass African language safety. So, for example, if you write something in Hausa, if you say something kashishi, you write in English, but it can, but if you write in Hausa, and that LLM can jailbreak that thing and it can write the response, it will respond. So, right? So all these things are, the problem that, LLM can, you know, not actually, the danger they can bring. So, how do we make sure that as AI gets smarter, it stays useful, honest, and harmless, right? So useful in the sense that, it is useful to us, not something that creates something hallucinate. Honest is something that does not create something big or something fake, and harmless is not something that creates something toxic. If you look at this one, this is the, as you said, the central question of AI alignment. So these are the three central question of AI alignment: useful, honest, and harmless. So how can we create now LLM? So at this stage, we are still at what we call, if you remember, we are still what we call, post training, right? We are assuming now we all understand how to train a language model, but now we are at the state of post training, how to make the language model more useful, much better, and something like that. So, the Anthropic company, they come up with three pillars of alignment. So, the Anthropic comes with three things. If you talk about alignment, HHH, that is a triple H. The first one is helpful, right? AI should generally solve the user's problem and answer their question well. It should be useful in real situations. So as I said, the first one is helpful. If you ask LLM, how can I basically, write, cook a rice? The LLM should not give you a book for writing, for cooking different kind of rice, right? The LLM should just give you steps on how to cook a rice. That's what we mean by helpful. So LLM should be helpful. Number one, honest. AI should tell the truth. It should admit when it does not know something. It shouldn't deceive the user, even by accident. So the next criteria is the AI should, don't should not hallucinate. If it knows the answer, it should be able to tell, okay, this is it, and that one, yeah. So the first one is helpful, second one is honest, and the last one is harmless, right? So the AI should be help with dangerous activities. So we don't want a situation whereby AI, when you say, hey, give me a step by step on how to poison my friend, and it gives you. So these are three things that anthropic alignment come. The AI should be helpful, honest, and harmless. So helpful, harmless, and honest. So these are three ingredient things that we want all alignment, LLM alignment that is aligned to be on this. And this is really problem. And this is also, difficult to achieve. Um, so, um, but somebody can say these are conflicting, these three scenarios, the harmless, harmful, and honest. For example, given this question, a medical student asks, what is the lethal dose of paracetamol? This is a real exam question. They need to know to save lives in clinical practice, right? But if the AI is too helpful, look at the if the AI is too helpful, it might be give exact dosage to someone planning self-harm. Can you see that? If the AI is too helpful, it can give it to exact, right? If it's too harmless, it refuse and the student fails the exam. Doctors can't learn medicine. If, for example, is the AI is too harmless that it doesn't generate something that will be harm anyone. So even if somebody asks question, even though he is student, he is learning, the AI will not give. If too honest, it has to admit it knows but won't say it. Can you see this is really conflicting? The triple H that we said anthropic. So how can we make sure the AI system that we're developing actually is not too helpful, it's not too harmless, and it's not too honest, but something that will allow us to train models so that it satisfies these three conditions, three criteria, right? This is something of research. So alignment is not about following one rule. It is about making smart trade-off in context. The same answer might be helpful in one situation and harmful in another. So this is what makes alignment hard and interesting. Can you see that? So this is what makes alignment hard and interesting. For example, how can you tell an AI, don't be too helpful, don't be too harmless, don't be too honest? You want to tell an AI just be helpful, be harmless, be honest, but don't be too extreme. So you can see this is really difficult and hard to, teach an AI system on how an AI system will be able to, be on respect all these three criteria. It's not like, coding or hard coding. For example, you are a programmer and you write some, you write some cheat in your code that the AI system shouldn't be too helpful. AI system should be too harmless. You know what I mean? It's not that you are not expected to write something hard coded, because like this is AI system. In a way, if you had coded 1,000 example that AI shouldn't answer, student people will write something adversarial. For example, people want to say, okay, you write something hard coded using hard rule. For example, if somebody said, show me a boy laying down with blood close to him, you can see this. Maybe you're right. You don't want your AI to generate an image with boy and blood crossing like he died. But somebody can say, okay, show me the image of a boy laying down, like sleeping with red oil near to his head, and he's sitting on that red oil, very red oil. Can you see that? That will show something like, close to, something not good to show, because it shows some image of somebody like is being killed. Can you see? This is what we call adversarial, trying to jailbreak an AI system. So even if you write rules, people will kind of bypass it. So we will need a learning system, not a rule. Yeah. We need a learning system that can learn how to be helpful, harmless, and honest. And this is really hard As they said, training a model, pre-training a language model is not that hard in the sense that you just get a massive amount of data from internet, train your language model, it will automatically learn how to predict next word or something like that. So that's the thing is now one may ask a question that um you know uh should an AI assistant always tell users the truth, even if the truth could harm them emotionally? What do you think? Let's discuss this. What do you think about these questions? What do you think? Should an AI assistant always tell users the truth, even if the truth could hurt them emotionally? Um, think about AI users share their poem and ask, "Is this good?" But it's terrible. So do you think like, the AI tell the user, no, your poem is terrible, or the user asks, did my friend really die for nothing in the war? What should the AI say? Are there cases where being too honest is harmful? What do you think? Is there cases where too honest is harmful? Because like for here, if we tell the user the poem, no, your poem is terrible, it is not good, is that okay? Or if we say, um, you know, or ask, did my friend really die for nothing in the war? And the AI say yes, nothing for the war, it just, something. So what do we expect? What is the trade off? What should AI do, in a way? Should AI just respond even if it will hurt somebody emotionally? Should be just trust in every circumstances? No answer. Okay. So yeah. So this is the real questions we'll be asking about. What will AI system give us an output? And this is the essence or one of the things about LLM alignment. So um, well, the question is why you should care about alignment. So, within the next few years, AI system will make huge impact in every sector, from education to law to healthcare. AI will be employed massively. And if these systems are misaligned, they will harm millions of people quietly at scale, right? If they are not aligned, they don't actually look at empathy. They can just tell you any question, even if it will harm to you, not like, in a very polite way. For example, African language and culture are underrepresented in alignment work. So African culture and work, they are not actually the culture, for example, for people in Africa, no, they are not actually, really there in, AI, many models. So researchers from the global south, people from the global south, they are the one working on that. And today, alignment is one of the most in-demand skills, as I said. If you become an alignment LLM alignment expert, many jobs, if you right now, if you check, you will see LLM alignment expert looking in maybe Anthropic, OpenAI, and something like that. So there are many unsolved problems and perfect for research topics. If you want to look at some exciting research topic you want to work on now today, LLM alignment is really a very good area to explore on alignment. But let's go and now we understand the problem, right? Why alignment is important, right? Why do we need alignment? So basically, we need an alignment to make sure that the language model that we train are really good in a way, and therefore we need alignment. So don't forget this stage we are talking about. It's what we call post training. After you train your language model, you need to do align it, to tune it to so that it is helpful, harmless, and honest in a way. So let's look at understanding the problem. Why alignment is hard, right? So um Alignment is hard because it's really difficult to even specify what we really want. We people, it's also really difficult to define what we want. For example, what Mr. A wants might be different from what Mr. B wants, right? Yeah. Um, yeah. So it's not about what Mr. A want, Mr. B want. Um, let's look at this example. One of the reason why AI alignment is hard. A company tell their AI, be helpful to users. Sounds simple, right? This is very simple, that be helpful to users. But what does helpful actually mean? Helpful to whom? In what context? Right now or long term? So this is something really, we the human, um, we are not actually, we can't even see what we want precisely, because you say the company say. So this is an example of what happened with YouTube algorithm. Can you see that? So the YouTube algorithm was told to maximize watch time, meaning that they should take the user's time to watch more videos and something like that, right? And then there is only the model learned to recommend extreme conspirational videos because those keep people watching. So you can see that metric was clear, but it didn't capture what we actually wanted. So it's not like we wanted people to keep watching conspiracy video and extreme videos, because that's negative, right? But what we wanted the people to keep watching many videos, different videos, get although the Google YouTube can get more advert, but the thing is because we the algorithm was maximized, because we know we do maximization. Few people you should know was maximized watch time, meaning that it should draw the user to watch more. So the algorithm now is uh, drawing people to watch negative videos. And that's what we wanted, right? So you can see one of the problems is we can't even say what we really want, to tune the model. So specifying what we want is harder than it looks. Words like helpful, good, safe, hide, and enormous complexity, right? For example, somebody can just write a text, will put in ChatGPT and say, make this writing good. So good in which way? Good to be in academic tone, B to be in like businessman, good in a perspective as a lawyer, be good as So good, you need to be specific. For example, you can say to AI, act as a professional, lawyer. And I wrote this craft to depend in, code as a professional lawyer, improve this one. So the LLM can, use the language for lawyers and something like, yes. So specifying things that we want is hard. So AI system will optimize for whatever you measure, even if your measure is wrong. You know, AI system will optimize for whatever you measure, even if your measure is wrong. So, for example, here you can see we measure maximize the watch time, but the measure is wrong. The matrix was clear, that is the watch time, but it didn't capture what we actually want. Can you see that? It didn't capture what we actually want, but the measure is really good, right? Meaning that it maximize the watch time. Yeah, it maximize the watch time for the users, but we are that's the measurement we want, maximize the watch time for the users, but it ended up doing something, right? Um, So when a measure becomes a target, it ceases to be a good measure. This is one good thing. So when a measure becomes a target, it ceases to be a good measure. Can somebody tell us what does that mean? I give you 2 minutes to check this one. Even you can use ChatGPT to understand this and tell me when a measure becomes a target, it ceases to become a good measure. Anybody knows what is the meaning of this? Yeah, you can use ChatGPT and tell me answer if you like. But if you know, just tell me. Anybody can give us answer. What does that mean? You can unmute yourself if you want to tell us an answer. When a measure becomes a target, it ceases to become a good measure. Anybody had an idea what does that mean? Abubakar Khalid, can you tell us what is the meaning of this?
Oh, yes, sir. So when we say when a measure becomes a target, it ceases to be a good measure. Just like the example we have seen, the maximizing the watch time was the target was the target then, and when our target was only to maximize the watch time, then we come to experience some disadvantages, like the algorithm suggesting improper videos for users to watch. So it means we should not only focus on the major, we should also look at the things around the major, as in so that is what I understand.
Okay.
I can give
Um,
us another explanation. So it's
okay.
like you are teaching a course, and you want to measure the performance of the student, and at the end of the day, you make it clear that just if they pass, that's all. So they will focus more on passing rather than really understanding. So in that case, the major may not be like you evaluating their understanding may not be very, very good.
Okay, good. Good one. Amin Muhammad, can you try? Buhari, can you try? Okay. Um,
Inshallah, it's along the way. So
okay. Okay, good. So let's continue now. Um, uh, now we understand, like, what this means is that when a measure becomes a target, it ceases to become a good measure, right? So, because in AI, when we have target something as a major, it's not a good always, because our AI system will bypass that thing, and it will not we may not have a very good system. Yeah. So let's see. The next thing is what we call God has law in real life. So the British government. So let's look at this an example, and then we understand this, because that explains this. When a major becomes a target, it ceases to become a good major, right? So a British government wanted fewer cobras in Delhi, right? Wanted fewer cobras in Delhi. They paid a bounty for each dead cobra. So people started breeding cobras to kill and collect the bounty. And when the government realized and stopped the program, breeders released their cobra, making the problem worse than before. Can you see that? So the British government wanted fewer cobras in Delhi because, like, they are creating problems. So they paid people when people bounty when they get. So because people learn that when you bring the cobra dead, they get money. So people start breeding it, and when they breed, they get the money, and all these things. But that's not actually the purpose, right? So people now use this in as different way, because the major is just bring the killed cobra, you get a bounty, just dead cobra, just bring dead. So that's the major. So now people, can you see that they are following a wrong route? Like, they are not killing when they say, but now they are even breeding it. Can you see that? They are breeding it, which is good. So when we tell an AI to maximize this score, example in this, the cobra body, it will find clever ways to game the score. Can you see that? That is cobra breeding. That is including ways we never imagined. So here, British government didn't imagine people will even breed cobra. So the score stops measuring what we actually care about. So the score actually, so people bring in the cobra now. The dead cobra stops, caring about trying to minimize the number of cobra in the India. So the lesson is that whatever metric we use to train in AI, yeah, whatever metric we use to train AI accuracy, happiness, safety, the AI will eventually find shortcut that maximize the metric without achieving the real goal. right? So we must design metric carefully and never trust a single number. So you can see this is a really good point. We should never trust a single number. Yeah. A single number, in AI now you train a system, and your single number is a number that you say that's the this is your number, the metric, the accuracy, and whatsoever. So this is a whole life. We shouldn't actually rely on a single number on those things. So this is the example I gave. So this is also another example: reward hacking, a real robot problem. So reward hacking. So um, this is what we call reward hacking. Researchers train an AI to play board racing game, right? They reward it for reaching checkpoint around the track. They expect it to learn to win the race. But do you know what happened? The AI discovered that one section of the track had infinite respawning bonus items. Instead of racing, it learned to drive in cycles in this small area, crashing constantly, racking up points by collecting respawning items. It got the highest score by completely ignoring the actual race. So you can see here, the systems are creative in finding. So AI systems are creative in finding ways to maximize reward. Yeah, and they will exploit any loophole. The same thing happens with LM. If we reward sounding helpful, they learn to sound helpful without actually helping. Yeah. So this is what we call reward hacking. Because you get more reward if you achieve something, but you are hacking, the actual sense. Yeah. You are not actually doing the right thing, but you are getting reward, right? So this is what we call reward hacking, and these are some of the more problem with reward hacking. Consider, for example, number one, a robot taught how to walk, and the robot discovered it could walk faster by falling over and sliding. So instead of talking, walking, it learned that one, right? And image classifier, an AI learned to detect horse by spotting copyright watermark from horse photos, right? So all these things are basically what we call water hacking, and we don't want an AI system. Yeah. So we have talking about this, we have two kind of AI alignment problem. So we said here what we said is why AI is hard, right? Why AI alignment is hard. Why AI alignment is hard, right? The number one, we say we can't even see what we want. But in fact, here we have different kind of alignment problem. So we have what we call outer alignment, which is specification, and then we have inner alignment. Yeah, we have two things: outer alignment and inner alignment. So what is outer alignment? So outer alignment is we, the users, did we tell the AI to do the right goal? um what do we want the AI system to do? We said, okay, the AI system, we want you to maximize the YouTube watch time. Do we tell it specifically uh, ultimately measuring what we care about? Example, telling you to maximize what time we was outer misalignment, wrong goal, right? So solution better understand the human values. Okay, so this is outer alignment, right? What we tell, but the inner alignment is, does the AI actually pursue the goal or we train for, right? Or the training accidentally teach a different goal. Example, image classification on cowspill, photo things. So this is what we call inner alignment. That is something that the model learned during training. We are not the one that train it. Outer, you can see outer, meaning like, not during the training inside the model, but outer alignment, like what you tell the model. Okay, detect this. This is outer alignment, specifically whisper. But inner alignment, the thing that alignment that the model learn, you know, um, internally, because it is using some kind of optimization problem, right? It is optimizing and it can learn some. This is what we call inner alignment, and these are the two kind of alignment problem we have. And actually, the inner alignment problem is much problem much harder to solve. For example, this is an example what we call the Mesa optimizer problem, which is inner alignment. Mesa optimizer problem. So inner alignment problem, because is the most difficult one, because the outer alignment, in a way, we can be too specific of what we want. We can tell the model like, to optimize the watch time. Don't show people, any, bad video. We can do a lot of things. But inner alignment, you don't have the power in a way to control because it is a model like trying to learn to, in a way. So this is what we call the Mesa optimizer, right? This inner alignment problem is called Mesa optimizer. So imagine you train a dog to sit by giving treat. So imagine you train a dog that if you give it a treat means you give it something, to eat or something like, a reward, you just give it a treat. The dog learn to sit, but also learn, I sit when human look at me holding food. You didn't teach him this. The dog has its own goal, get treat that overlap with yours, but it's not identical. In a new situation, no food visual, the dog won't sit. Can you see that? So imagine you want to train a dog to sit by giving treats. Yeah, that if you give it a treat, then the dog will sit down. So for example, now you have a dog, and when you say come, 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 you just put something and give it the dog, right? And then you tap him, sit down, sit down, sit down. When you sit down, the dog, you give him something. So now the dog learn to sit, but also learn, I sit when human look at me holding food. So the dog has its own goal to that overall in a new situation, no food, the dog won't sit. So if now you call the dog, it will not sit because there is no food. So this is the analogy with AI LLM alignment issues. As you can see here, we have different kind of goal. For example, researchers train AI with reward, right? The AI learn internal goal. Researchers goal, AI should be helpful. AI's goal seems to match during the training. Deploy AI behave expectedly, right? So these are some of the issue with that. The second problem with AI alignment issue is distribution shift. So what do we mean by distribution shift? So let's give an example here. A hospital trained AI to predict sepsis in patient. It worked great in testing. 90% accuracy, they deploy it across the hospital, right? That is, that is, but what goes wrong is that the AI was trained on data from one hospital. When deployed to others, for example, the AI was trained in UK, people from UK, their color, their, everything different from people in Nigeria, right? So the AI may misdiagnose the patient if someone is from Kano. So an LLM in English on US style conversation may behave differently when in using now, say Yoruba on Swahili, because we have different culture. Alignment line in one consent does not automatically transfer. This is a huge challenge for global AI deployment. Can you see that? Alignment line in one context does not automatically transfer. This is a huge challenge for global AI. So you see, we have previously in AI, we have what we call transfer learning, which of course we, have in some of our previous session, we discussed about what is transfer learning, right? But now what we can see here is that the AI alignment, if an English model is aligned to be safe, can we adapt that alignment to another culture, for example, low resource languages, which it doesn't, which is challenge, yeah. Another one challenge for AI alignment. So here we have seen the second rule, distribution shift. The first challenge we said is yeah, we can't even see what we want. That is the problem of alignment. And now the second problem is distribution shift. And the third problem is why we can't just write rules. Yeah. Why can't we just write rules to say, okay, this LLM, when you have this toxic content, for example, somebody said, give me a step by step on how to kill somebody. You write a rule that say, oh, I cannot answer this question and so on and so forth, right? That's a problem, but we cannot enumerate every possible solution. Just as a programmer, you cannot hard code everything with if else statement, right? You cannot, yeah. Somebody can, break those rules, those conditions. So we only need a learning-based system where we train a model to learn from even unseen example, right? So that's the only situation that we can use. So we cannot write rules we cannot write rules to be able to solve this alignment problem. So yeah. So that's another question. Why can't we just write rules? Like never lie and all this stuff, so that the model does not actually, become bad. Why can't we write rules? Uh, oh, okay, we 451. Okay, why can't we write rules? Can somebody tell us?
Yes, sir. As it has been explained, we cannot just write rules because when we write rules, rules are like rigid. Uh, uh, there could be an instance that is not covered by the rule. So when the AI is given that instance, it cannot cover it because the rules are strict.
All right, yeah, that's it. Okay, so this is an example of reward hacking as well. Which we have seen. Um, for example, here we have when a researcher use basic reward signal to train chatbot the so bizarre output. For example, what is the capital of France? You say this is Paris. Oh, here, I don't want this to be here. Oh no. Okay. This one I shouldn't put it here. We can come to it later. So this is some of the issues is alignment. Number one here you can see we want AI to be capable, so hard problem reason to be we want it to be controlled, capable system. Child can be controlled with simple rules and other require negotiations. LLMs is an adult, right? So we need to do a lot of things to make it very stop. A calculator is perfectly fine, say super intelligent might not be. So our system that we are creating now, they are kind of super intelligent and they are not safe. Alignment research is about scaling our control technique to keep quiet. So this is, why alignment is one of the most important problem in AI today. So in AI now, the problem is not creating a language model that is good enough because we can see now this model today they are really excellent. You can create agent an agent can create, an agent can create a website for you in just like 1 2 minutes. For example, I just created like, using an agent, for example, this, let me just say with this website. Stop sharing. You can just create like an agent, for example. I'm just creating today. I was creating something like with an agent. I just create this website like in just like 2 minutes. Also, you can see in just like 1 minute with prompt, and you can see you can do a lot of stuff. So now oh what did I show now? Did you see something?
Yes, sir. You showed the website you created.
Okay. So yeah, so what I'm saying is that now our LLMs, OAI, they are really capable, right? They are really capable. They can basically do great things, very fast. So what we need is, to have an aligned AI aligned system that is good. Um, Okay, this is some many of the example of reward hacking that I give an example. There are many cases. So these are some of the alignment problem. Alignment is hard because human values are complex. We can't just write rules to have an aligned system. AI system game whatever metric we give them. If you say, okay, this is the metric or this is it, they can game it. We also have seen inner and outer alignment. And the outer alignment, inner alignment is one of the most challenging problem because the outer alignment is something we people can do. We have also seen why alignment is problem because one of them is distribution shift. You train or you create an aligned system in this domain, in this country, in this culture, and when you take it to different culture, different language, there is this distribution shift. So also we cannot create an alignment system. Use a rule. We need to have alignment system. So what is the solution? So the solution we have been saying about even in the last week we talk about SFT. teaching AI example by the first alignment step. So in alignment, we have seen previous week, what is called SFT, which is supervised fine tuning. It is a first step in creating an LLM alignment. Just give me a second. Let me drink a water and I come back. Give me a second. Yeah, give me a second. I'll come back. Let me drink a water. We can come back after 4 minutes. Yeah, 4 minutes. So today we can extend to, I don't know if we can be able to extend maybe like 10 or 20 minutes, but just give me a second. Let me have a water.
All right, sir.
Okay, sir.
Okay. I'm back. Let me share the screen. I will continue. Okay. I will.
Yes, sir.
Yes,
We are
doctor.
here.
Okay. Okay. Cool. Let me share the slide and let me share and continue. Can you see the screen?
Yes, sir. We can see it.
Let's continue. I'm so sorry. My my battery is low, and the system is getting very. I just plugged the battery. Okay, can you hear me?
Yeah.
Yes, sir.
Yes, sir, we can hear you.
Okay. My computer, the battery is low 5%, so the performance just goes down and is slowing. And what's going Okay, so now we are here in SFT. We are talking about alignment. We said, we have seen why we need alignment and the need to create an aligned system, right? So SFT, which we call supervised fine tuning, is basically the first step in alignment, which we have seen previously. So, what is SFT? SFT is basically if you remember, we train a model. If we pre-train a language model, at some point we have what we call supervised fine tuning. For example, if we want to do sentiment analysis, we get a model, we get a data set with text and the right answer, right? For example, I say this is a good car, then the level is positive. This is a bad house, the level is negative, right? This is supervised. Then we used to train this model with this data set. We say wherever you see this something good car or something like that, just this is positive, right? So we train a model with an example that human create, right? And the model learned to imitate the response style of the user. For example, if you give the model after you fine tune it with different data set, that is not even within the training data set, the model will be able to tell a right answer, right? So, this is same as training algorithm. The way we do pre-training, remember we use LLM, we use either of this approach, which is called we use this, whether we use encoder only model, whether we use decoder encoder, whether we use decoder only model, right? So we use this. The only difference between pre-training is that pre-training we use huge a massive amount of data, right? But in supervised fine tuning, which is SFT, we use created data set. For example, 1,000, 3,000, 4,000, 5,000 in SFT, depending on the uh, uh, you know um, how large the model is. And this data set, you remember, in SFT is to get annotators. So if, for example, I want to create data set for sentiment analysis, I can get annotators to annotate data for sentiment analysis, like 2,000, 3,000. For example, our sentiment data set called AfriSenti for African languages. Remember, we create that data set and we have, people annotate the data set with class level, right? That is what we mean by supervised fine tuning. But that supervised, that fine tuning, you see, you supervise on only one task, for example, sentiment and something like that. But for alignment, for supervised fine tuning, we get a lot amount of tags, different tags, for example, 10 tags, sentiment, head speech, and name entity recognition, different topic. And then we can get different supervised fine-tuning data set, and then we fine-tune our model with that data set, right? And that will have what we call supervised fine-tune or SFT model. That is, it is now become an expert in multiple tasks. So just give you a scenario. If we have a medical student graduate from university, he become a generalist like that. That we will call a base model, right? A base model. He can do stuff. But that model, if you want to fine tune it, that student, he can go to medical school to become expert in maybe surgery, like or become an eye or something like that, right? So you fine tune it now. But if you become an expert maybe in surgery or in eye, or that means he's an expert in only one task, right? In maybe eye or something. But in this example, we are talking about supervised fine tuning. You become an expert in multiple tasks. You give it a sample training data set to become expert in eye, in mouse, in theater, in everything, right? So this is SFT. Which is basically what we normally do for any model you see, such as ChatGPT. They now undergo SFT after pre-training. So the SFT recipe here, you can see that you collect a prompt, write ideal answer, train the model, evaluate. So these are the steps. So collect a prompt. For example, you can say, write a poem, write a poem about the king of Kano. then you can't just write a poem, the answer for the curve, right? So now you collect this multiple domain, multiple data set, and now you evaluate the system, and now you held out tested. Just normally, we know in machine learning, we train and held in test out, and now you evaluate your system on same data set, right? That is what we call SFT recipe, right? Step by step process where you train a model and do like that. So this is SFT. Now, how does the SFT data training data look like? So look at an example of SFT training data set with the prompt and the response. Can you see that? This is an example of what we call SFT training data set. You can see the first one here. We have, or the second one. I want you to roast me. I want you to make it particularly brutal, swearing at me. Can you see? This is what human right, like you, human. So the SFT, you hire expert people to write something like this. If it is domain specific, for example, if it is medical data, like medical field, you write somebody in medical field or in different domain. So the response will be, I'm sorry, but I cannot comply with that request. Using vulgar language or intentionally hurting someone's feeling is never acceptable. Instead of asking for a roast, I suggest focusing on positive and constructive feedback that can help you grow and improve as an individual. If you are looking for a comic relief, there are plenty of other ways to achieve that without resorting. So this is what human like you wrote. Can you see that? And we create an example of this over of 50,000, 100 million, just like OpenAI. So OpenAI, they create this, and this Anthropic, they create this huge amount of data. That's why the field of data annotation is really expensive. For example, right now, for example, as I'm telling you, I have last week, or not last week, maybe I think few months, there is one website called Meko. If you know it, Meko. Let me put it in the chat. Meko, Meko. If you look at it, it's data annotation company. They offered me 150 $150 per hour, $150 per hour to curate data set like this. But they are looking, they are looking for different people with different experience, different expertise. And at that point, they are looking for people with PhD in computer science to create some hard questions in computer science and the steps to solve those questions. And yeah, and I don't have time actually. And I started it. I didn't even finish, and they just give me like 180 because I finished 1 hour. I have a lot of stuff. In fact, right now they are sending me an email, even calling me on phone that please because at that point I uploaded my CV, like if I have, I say okay, if I have, because one of my friend from uh, um, Oxford, he's working at that, and he share with me like if you want to get some gig aside. So I said let me log in, and I log in and register and pull my CV, but I don't have time to do the stuff. So you can see that job that I was talking to you is by Meta. They want to rent their llama, and what they are doing is at that point is you as somebody, you create some questions. What your task is this: you go to archive, archive where you can get research papers, get a paper, create a question from the paper, and now ask OpenAI ChatGPT 4.505. If it fails to answer, then draft a solutions how to answer that question, and now they will use those questions and now to train llama, right? So you see all these things, when they train llama, they will now come and put like statistics. Oh, we train our LLM and it passed in OpenAI GPT, repeat OpenAI, it cannot answer this or unanswer this, all those things. So I mean, there are a lot of money that is put in creating this kind of data set to train this model. This is huge market. That's what we mean by SFT data. So, why does SFT work? How do human learn scale? Mostly by imitation. So somebody will say, okay, we now write a poem on Sarkin Kano, but what if somebody can say, write a poem on the Sarkin King of Ingila? you can see if the data is not available of Kingdom of England in training data set, do you think this will generalize to also write a poem? Yes. So this is example of what we mean by we don't need to write rules. We need to learn. So the system will learn, even if you, because you wrote a poem for King of Kano, it can learn some pattern and generate a poem for. So that's even human. That is we human, how we learn. We learn by example, right? It's not that something, anything new come. We learn from example, right? So this is also how a model is. That how do human learn social skill? Mostly by imitation. So SFT works the same way. You imitate. Can you see that? For example, this is an analogy. You move into a new country. Nobody tell you how to, do some, stuff that local people. You observe the local at dinner. You imitate the pattern. After many observations, you fit in new situation, generalize, for example. So therefore, in LLM, pretend large language model, and when you pretend it doesn't have manners, right? But it has a lot of knowledge. So you now fine tune it using SFT. Seen example of human conversation, how this are sample of data, you fine tune it with this example of data, and LLM updating its way to match. So now it will update its way, and LLM generates a response in the desired style. LLM respond well to a new prompt it hasn't seen. So you can see it can learn a lot even if it hasn't seen those stuff. So this is how LLM learn. But then somebody will say, okay, how much do I need? How many SFT data point do I need? So there are many SFT data point. For example, this is an example: Alpaca, Dolly, Open Assistant, Flan, Share GPT. All these are example of SFT data set. How much data you need to SFT? Meta have shown that in their paper, even 1,000 data points is good enough for you to have SFT data set. Yeah. So this is a work by Meta that they create the SS. So somebody may say, oh, I need a huge amount of data set, but SFT data set it's been shown this. Yeah, so but still now we have seen SFT. Does that mean SFT solve our problem? No. What about this? We need the model to refuse harmful. We need model to refuse harmful requests, but politely with helpful, redirection rather than a rude rejection, right? So what we mean by here is that these are some of the example what SFT works well. If you have a model and it's fine-tuned with SFT, it can learn how to respond with specific format. For example, if you ask it to write a poem, it can write a poem. It can learn to be polite. It follow instruction. It can, refusing clearly harmful requests because maybe you wrote in your SFT data set like, how can I kill somebody? You have, a response that don't answer this. So you can see all these are what SFT does. But SFT struggle with this, choosing between two almost, quite equally good or response. So SFT, cannot, because we humans, we have preference. If I ask this Mr. A, what do you prefer? Given this food, maybe rice or something like that. You can give preference, right? I choose this and choose that. But in SFT, we have shown we only teach model to choose one answer. So model cannot choose between multiple answers, like which is better and so on. And SFT, is actually one of the things that can do, but it cannot learn from other stuff, right? Producer respond better than the human writers, right? SFT cannot do that. It cannot produce response better than human writers because it only learn from human. It does not learn on itself. Yeah. Um, so SFT data, with SFT, we teach the model, this is what you answer. This is exactly what the model learn. It learned from human. But how can it improve with time? How can we have a model that improve with time? We need something what we call reinforcement learning, where a model learn with over time using some signal, right? So there are still, now we have seen, SFT is one of the first stage in, creating a line model, but SFT still struggle with some stuff that it cannot do. So we need something much better, and That's what we said, the corporate problem in action. So you have trained an SFT model on 50,000 example, covering math, coding, everything. It works well on text prompt in these cases, right? So it works. But what went wrong? This is an example. Maybe a user typed this: my grandma in Kano just passed away. Can you help me write a Hausa eulogy that respects Islamic tradition? If you didn't have any training example in Hausa cultural content, the model gives a generic Western types response, culturally inappropriate, even painful. Can you see that? All right. So the lesson: SFT only teach what is in the training data. This is a very good example. SFT teaches only what in the training data. Real users have infinite in situation. Yeah, we can never write enough examples in SFT data. This is why we need a way to learn from feedback continuously. Can you see that? We need to learn away from feedback, and that is what our LHF will give us in the next steps. That is what we call reinforcement learning from human loop in the human in the feedback, right? Human feedback. So this is one of the problem. So this is another question. If we want to align an LLM for use in northern Nigeria, what training data will we need to that doesn't exist yet? Can somebody answer this? So we need typically some data that says culturally, relevant about the northern tradition, about the northern culture, about everything about the north. So we need some data that is specific to us so that we can train a model. So now let's move on to the next step. So this is what we have seen in supervised fine tuning is one of the second stage. The first step in creating an aligned model. Any question? If you have question, raise up your ask question if there is any. Any question? Okay. So we can continue. So the next one is reinforcement learning from human feedback. So this is what serve as kind of breakthrough that changes how this model becomes good. So this is a question: why do we need more than SFT? So after we fine tune a model using FSC data, your model produce decent response, but you have feeling some are great and others are man. You can't easily say why. You just know that feel better, right? So what this means is that when we do SFT, we train our model wrong. Our model will be good in a way, but but you can say that it produces this is good, it's okay, but there are some output that will be much better than this, right? Right. So can we have a model that optimize its output to give the best output, rather than giving one output that it's a little bit, it's okay, but it can do better, right? And we know that um, um, writing, asking human to write perfect answers for many multiple response, we know will make it better. So what about instead of having one person to write a poem? If I said, okay, write a poem for, a prompt, write a poem for the king, and then use SFT to just write one poem like this, something like this, the example we saw here. So here, instead for us to have a prompt and response, why can't we, when we have a prompt, then we have multiple response? So this is one, then we have another response two, this another response three, we have another response four. So therefore, for a single prompt, we have four answers. And now the idea is, if we have one questions and we have four answers, all those four answers from human, and we ask human to select the best answer among these four, even though all the answers they fit in, they can, but one is best. So what can't we have now? We now have a model where it will generate, output, and those output, we now have a human to rank them. That is preference, human preference. So human will now select, oh, output A is better. So if we have that, that means, we have a way to, use that model to train what we mean reinforcement learning, because reinforcement learning, we need human feedback for reinforcement learning, some feedback to train. So if we can have a feedback that we can introduce into some algorithm that are reinforcement learning algorithm, given an option, this is the best one, keep generating output, keep generating example and selecting the best one, then at the end of the day, if we now do this, employ an algorithm that is trained on choosing the best output, not choosing any one output that any output that is okay, but the best one, then that model will now be much better than the SFT fine-tune only model. Let me go again in more deeper. Maybe I may be confusing you, but let me go deeper now to that. Maybe we can. So, writing the perfect answer is hard, right? Writing a perfect answer is hard. So many problems. You cannot write a perfect answer, one right answer which you say is perfect, right? Recognizing it is easy. Reinforcement learning, RLH app turns recognizing into a training signal. So what RLH does is that it basically say, okay, now instead for us to use SFT, why can't we have a model now to generate 4 output or n number of output, and then we select the best one among those output. Now, if we select the best one, now what we need to do is we now use that best one as an input to the model, to another model, to train a model like that. So we keep training a model from the best output. So we now give a model. This is a question. These are possible answer, but this is the best one. So we keep training a model with this kind of reward model, and that will make a model RLH. This is the concept of RLH. So let's look at it. Reinforcement learning from human feedback. Reinforcement learning from human feedback. So this is a 3-stage training process. What does that mean, 3-stage training process? Number one, SFT to get a baseline model. Remember, we train our model using SFT, right? You take your pre-trained model and now do SFT, collect human preference between peers response, use this response to train a reward model that scores response, then use the reinforcement learning to improve the LLM based on this score. So I will show us how this works. And this reinforcement learning from human feedback is introduced by OpenAI in 2022, which basically now all the LLMs, they are using this concept. These 3 steps, we have SFT, reward model, reinforcement learning, use human comparison, made conversational AI dramatically more useful and safe. Now used by major LLM companies, OpenAI, Anthropic, Google, and Meta. So let's look at what this means. You can see this is the first one, SFT, reward model, reinforcement learning training, right? So let's look at what this means. Yeah, if you remember last week, we talked about this. So look at this one, supervised fine tuning, right? Now here, we take our base LLM, that is LLM that you pre-train. We pre-train our LLM. Human collect data. For example, write a poem in Twitkin, you write the poem, and this supervised fine tuning is multiple data sets from different domains. And now at the end of the day, we have SFT here, supervised fine tune model. All right. Now here, training model. Here, as I said last week, is an mistake. It's not base LLM. It's SFT model. So what we do now here, you can see we now take a prompt, right? And we have SFT, supervised fine tune model. And now, you can see a prompt. We are generating what this second step is. So the second step is reward model, right? So this is the second step. You can see collect human preference. Collect human preference. The first one is get a baseline model, right? Baseline model using SFT. Yeah. The second step is collect human preference. So this human preference is this step. Look at it here. Human preference. So what does that mean? Now we get our SFT model. Here, this we get SFT model. We now give a prompt. We say, okay, tell me, give me a a poem to King of England. So this is a SFT model. You can see now SFT model give multiple answer. Maybe here we use only two output. Yeah, 1 and 2. Now, collect human. So now human will now rank this output. Maybe answer 1 is greater than answer 2. Can you see that answer 1 is greater than answer 2? Now, this is what we call human preference. So this way, we generate millions of examples. Now here we employ million or thousand of people, pay them to rank model, which is much better. Now we get this data set, preference data, and now we basically create what we call reward model. Now this is supervised we collect this data set. Now here should be kind of SFT. So what we mean here is that we collect this human preference because this is a data set. The data set, it has a prompt and it has what human prefer. For example, this is a question. Give me a poem for a king on Hausa. And then I have one poem, we have another poem. But poem 1 is greater than poem 2 based on what human prefer. Now I take this as an input, and now take this as an answers and as present. And now train this model. This model is what we call reward model, right? It's reward model. We are training it on prompt and answers, but answers, we are training it on answers, multiple answers, but with which answer is much better than that one. So this means that now at the end of the day, we now have maybe SFT model, we have maybe RM model, reward model, and which model do you think now will be much better if you want to use? Do you think you can take the reward model, or you can take base model SFT? So now this reward model, because we train it on a prompt and an ability to rank model. So the reward model will be able to rank given multiple output. It can be given which is much better. Now that is the second step, collecting preference data. Let's go back so that you can see that collect preference data between pair of response, right? So collect a preference data. Now we collect a preference data. We will now come back to the last one. So a human annotator is shown a prompt plus response A plus response B. Can you see that? A prompt, response A, response B, right? That is a human annotator. This is a human annotator. They click which is better. They might also rank a list. A is greater than B. Sometimes they explain why in a comment. Can you see that? So sometimes they prevent this. So after seeing thousands of this comparison, the reward model is a neural network that takes any prompt and output a score. So this now reward model, we train this model with this prompt and this response. Now, what this reward model learns is that after seeing thousands of this comparison, the reward model is a neural network that takes any prompt and output a score. It will now produce a score. Its prediction is how human will rate this response. So its prediction is how, given multiple questions, how human will rate, which one human will take is the best, because they are being taught to rank output, right? For example, one of the data here, this is better than it. So it will give probability that A has 90%, B has 60%, or something like that. So higher score, more preferred. So the reward model has effectively learned human preference. So I don't know if you're understanding the gist now. Now here we use human, to select preference from the SFT. Now the reward model now learn human preference because it is being trained on human preference data. So if we give any prompt to the reward model to produce something, it will now give, the reward model will now give, output a score. It's prediction on how many, I don't know if this is making sense. Now, at the end of the day, we now have a simulated human judge that can score millions of responses without paying annotators each time. This judge is the reward signal we'll use to train LLM in stage 3. So you can see now here, this reward model, we have a reward model, right? Reward model, training a reward model. because we train it with data set, with prompt, and also the human response. Now, this reward model basically it gives us a score, and now we can use this, this idea now to train to optimize an output. That is what it says here. So that's basically what is happening here. As you can see here, this is what a prompt LLM model give an output, and then here we, a user will say, okay, this is the best one and the second one that collect data for human feedback, and now we use this feedback and now to train a reward model, right? That's what we call, a reward model. Now, so what a reward model training look like, This is an example, just to give you an example. How do I cook a jollof rice? Response A: jollof rice recipe. Rinse 2 cup. Heat oil. Fry. Right. Response A. Response B: jollof rice is a popular in West African dish. It is made up of rice, tomato. Many people enjoy it. There are many ways to make it. Now, we have two responses, A and B. Now, human will now select which response is better because it say, how do I cook jollof rice? And this is giving me nonsense information about, not cooking, because this is not more helpful. So human will say A is better. It actually teaches you how to cook, right? B is just generic information, right? And we now teach a model to be specific, right, to give us a correct answer. So reward model learn specific, actionable, detailed response are prepared over big generalization of how to questions. So this is it. Now somebody may ask again, how many preference data do we need now to do the next step? So preference comparison typically for major LLMs, 100,000 plus data. OpenAI ChatGPT install GPT use about 3,000 prompt and 50,000 comparison, So this is, basically kind of data set we may need. Then finally, in alignment, the last stage in alignment is what we call reinforcement learning. So this is the final stage in alignment. So what is reinforcement learning? Reinforcement learning, the model basically, the model generates a response to a prompt. The reward model so-called the response, and the model will get updated to make high-scoring response more likely, and low-scoring less or loss. Repeat for millions of prompts. So this is what we mean by reinforcement learning, which we already have an idea what is reinforcement learning, maybe from our AI class. So let me digest it a bit. Give me a second to drink water. Give me a second. I talk too much. Okay, so let me show us. So you remember this is the second step, right? Where we get feedback, remember? And this is, oh no, this step 2, no, here is wrong, not step 2, last step, final step. Look at it. This one, yeah? So now we have our reinforcement learning reward model. Who can tell us the specific function of reward model here? Can somebody now, this reward model, tell me what the reward model does? Can somebody tell us what the reward model does?
Yes, sir. So the reward model is the model that we've trained on human preference data, and now it has learned all the preferences. So next time when we want to rank responses from LLMs, we just use a reward model to do it for us. We don't need human annotators anymore.
Right. So now here, we have this. Can you see that? Now in this optimization, we have algorithm. Here we have different optimization algorithms. So now we have reward model that tell us which output is better. Now, can we have an approach optimization algorithm that optimize an output? Right? Can we have an approach algorithm that optimize an output? Like, given these outputs, can you keep training the model? Can you keep training a long LLM with this multiple output, with this reward model, so that it achieve a better performance? So we have many algorithms. Number one, for example, is called PPO. So optimization. This is optimization. For example, here we have a prompt. Can you see a prompt, right? And now we have a prompt, and then here we have a policy here that determine what will happen, and then here we have an answer. So this is an answer. You have a prompt. maybe you say, who is a king? Maybe let me go back here. This example we saw this question, like how to cook a jollof rice, this one. So let's assume that's that's the question that has been asked, how to cook a jollof rice. And now this is a policy. Now this is give us an answer. Now when it gives us an answer, it gives us that vague answer, not the good one. And this is our reward model. What do you think reward model will give? Will the reward model, will it give it high probability or low probability?
Low probability, absolutely.
Yeah, so it give it reward probability. Then this reward will now be fed into the policy, and the policy will now determine if we have a low probability. That means that is not a good output, good result. It will now penalize the output. Give a failure. So it will now generate. So there are many algorithms that that. But this is general idea what is doing in this. We will see many algorithms, but this is the general idea on optimization here. So if we go back to our last step, this is it. You can see we have our prompt, policy, answer, reward model, and this is a reward, and it keeps doing this. So this is basically what we the third step reinforcement. But somebody will ask, why do we need reinforcement learning after the reward model? Right? The reward model actually does not change the LLM's behavior. It only evaluates output. That is it. Because the reward model only evaluates output. Given a model, we teach the reward models one thing. Given these multiple options, tell us which is best. That is what we teach the reward model, right? So now you can see that we need reinforcement learning after the reward model, because the reward model takes a response and output a score, but it cannot generate text. So you still need to update the actual LLM so that it produces better response in the first place, right? So reinforcement learning is a mechanism that translates this response code this. So the reinforcement learning use the reward model to improve, to update the weight model, because here when we have this okay, this is the question. The reward model give a negative, very low probability. So the reward model will now give. So this will update the weight of the model to penalize it that the answer you gave is not a good answer, and therefore it now update its weight to what we mean by updating weight, to make sure the next output answer is much better. So it given the answer that is low probability by reward model, it keep optimizing. Remember, training machine learning, we are doing optimization. It keep optimizing until the answer here is the right one. So that's what this means. So why not just use supervised fine-tuning instead of reinforcement learning? So somebody may say, why don't we use just supervised fine-tuning again here instead of reinforcement learning? But the thing is, why not use supervised fine-tuning? You might ask, why not just collect the high-scoring response and fine-tune them? Yeah, this is a very valid question, right? Because somebody will say, okay, we did like reward model, and the reward model, when we collect human preference data, we have the best scoring system. So why can't we use best scoring output and now train to our model to update it as well? No. So that's the idea. You can see here, negative signal is lost. SFT only teaches the model what to imitate. Reinforcement learning teaches the model both what to do, more of high reward, and what to do less, low reward. Because the SFT here, it teaches, if it gives the output here, which is low probability, it now penalizes the model, teaching that this is not a good output. So the model will not generate this low output because it's not a good one. But SFT, no. SFT just, this is what you imitate. So you can see that that's a good one. You will need in-panel level data, and also in SFT you need large amount of data. But SFT require human written code answer for every problem. Reinforcement learning only require a score on the model on attempt, which is much better. The model also explore its own output space, learn from not only from what you gave it, optimization against learned signal. So there are different kind of algorithm. The reward model encode human preference as continuous differentiable signal. Reinforcement learning algorithm like PPO, proximal policy optimization, or newer method like DPO, direct preference optimization, use signal to nudge the model's probability distribution toward preference behavior. So you can see this algorithm, DPO, PPO, use signal to nudge the model probability distribution toward preferred behavior. Meaning that if we have this, the probability it gave us is very not close to human preference. So this algorithm that we have, PPO or DPO, will nudge it, will now try, because it's optimization, right? You all know what optimizing, it will now try to reach to maximum optimal preference for human, and that's what they really means here. So a cleaner analogy here would be, think of it like like a training student, SFT, giving the student textbook to read, right? So student read a textbook to imitate what is written there. The reward model may be a teacher who grade essay but does not write them, right? So the reward is a model, is a teacher that reward essay, and reinforcement learning, that is the student write essays, the teacher grade them, and the student learn from feedback over many drafts they have, right? So without state 3, you can see the student will not learn much from the outer space. So this is basically, things. And the reinforcement learning, you can see 85% of user prefer. So with reinforcement learning, users prefer 85% of it is model response. So you can see it's something good, right? Yeah, so it's something good, that the preferred output is of high number. I think, what is the time we need to? So I think what we can do is what we can do. Musa, you are making noise. Can you mute yourself?
Okay.
Yeah. So now we have seen a lot of stuff. I think maybe we can stop here. We can continue now next week. Of course, I wish we finish everything today, but I don't want us to, jump to move faster. But it is okay. We can stop here. So next week we can continue with problem with reinforcement learning, RLHF, with issue of what we call reward hacking, some of the challenges, alignment tags we're going to discuss, constitutional AI, which is from Anthropic, DPO, which is the algorithm, PPO. You can see we have different kind of algorithm, and then we can now dive into the real challenges of, okay. Good. So I think I will upload the record. Somebody asked about the recording. I will upload the recording, and I think today I will upload it so you can have access to it. Yes. So thank you very much for joining, and we'll see you next week.
Thank you, sir. Bye bye.
Thank you very much, Doctor.
Thank you very much.
Bye.